Alright, today we're going to examine some Orient watches. We're at the School of Horology in Columbia, Pennsylvania, and we have a timing area where we actually test the timing on the watches. So come on in and we'll take a look. Now the upstairs part of our school has a service center. Inside the service center we have a chronometric observatory where we do some testing of watches. So we're going to check out these Orients. I've been checking them for 16 days and we'll come up and we'll see the results. Our school our service center is behind the door and it's always locked so no one can have access except authorized personnel. That's where we check the watches. Okay, in here we have our incubator, which we check the watches in. This came from the University of California. It keeps a constant rate of the three temperatures which we need. One is 68, one is 41, and the other is 95 degrees. Okay, since there's no place in the United States to test watches for timekeeping, we decided to start our own little mini observatory. Now, okay, we're using as our testing standard the U.S. Government Department of Commerce National Bureau of Standards, the testing of timepieces. They stopped testing timepieces in the United States probably in the 1950s. This is an older book. In fact, the National Bureau of Standards changed its name in 1988 to the National Institute of Standards and Technology. But we'll use the criteria that's set out in that book. Although it's not as stringent as what's used today, it's still a very good copy, a very good test of how the watches run. Basically, we have a sheet, and we test the watches for 16 days. Now, on day 1, we run a temperature at 68 in the pendant up position. Day 2, 68 pendant right position. Day 3, 68 pendant left position. Day 4, 68 dial down. The 5th period is 68 dial up. 6th period is at 41 degrees, and that's in the dialed up position. And then we switch on period 7 to a temperature of 95 in the dial up, and the last period, 8, is 68 degrees, and that's pendant up. Now we test these for 2 days in each period and then take an average on the side. Now the bottom line, let me show you these watches. The bottom line is 3 of the 5 watches actually did pass, and we were able to issue certificates for the 3 watches. Now the watches we have, this is number 1. We'll just show a picture of it. Number 1. Now the second watch, number 2, is one that actually earned a certificate. That's number 2. Number 3 is this one. All these watches are automatic, and they all have power indicators. Some have days. Most have days. In fact, they all have days. Looking at it, they all have days. And number 4, this was actually the most accurate of the 5 we tested. That came out real good. And the last one was number 5. This also earned a certificate. And it's a nice model watch right there. Now, to keep from getting everybody really bored, we're just going to get into the watches that passed. The number 2 watch, if you can zoom in on this, we can give you the actual results. The tolerances are on this side. The actual is on this side. And the criteria for this, rather than sit here and try to talk to you, will be on our website. So if you want to go to nawcc.org or go to horology.edu, you can actually locate the criteria we use for testing these watches, and these results will also be posted on our website. But this was good. The best watch was number 4. This had outstanding results. Now these watches, again, were stock watches. I didn't touch them, I didn't open them, I took them from the box and just started the testing. So the way it worked, I ran it a day, I wound it on our automatic winding machine, which is this machine over here. We put the watches on. I allowed it to wind for 2 hours. It went from it'll completely wind the watch in 2 hours. And then we put it back in the machine, in our testing machine, and we ran it that way. So each day I took it out, wound it for 2 hours, and then put it back in for the testing. The results on number 4, which is this one right here, were really outstanding for a stock watch, and at the price it's just amazing. The biggest variation was 6 seconds. The temperature error was 5 seconds, which isn't too bad. The problem these other watches had, the other 3 actually did pass all the other tests with the exception of the temperature test. When it went down to the 41 degrees, it had a big variation in, not a big variation, but it was like 2 or 3 seconds over the maximum allotted time. And that comes from generally a hairspring quality. They make different quality hairsprings. I think if you put a very high-grade quality hairspring in here, it would take care of the temperature error, and they probably would have all passed in this criteria. But the watches overall, over 16 days, I was very impressed. They all came out well, and 3 of them actually did pass our testing. So if this was back in the 50s, they would have received chronometer certificates from the National Bureau of Standards. But since they don't do that anymore, we're about as close as you can get to actual testing. What I used for a master time source was the Naval Observatory atomic clock. I got the time from a signal from them, so it came right from an atomic clock. So that was very accurate main source we had. The next video we're going to do, I'm going to actually take a couple of these watches apart, and we're going to compare the rates, and I can show the hairsprings and the different ways we can probably adjust these to make them run really, really good.